Okay, ladies and gentlemen, today we're going to be talking about geometric mean and how it applies to right triangles. So the first thing we need to talk about is what is the geometric mean. So the geometric mean between A and B is defined as the square root of A times B. That's all there is to it. That's all that it means. Take the square root of A times B. So when we look at our example here, and I say, okay, what's the geometric mean between 8 and 6? Well, that means you're going to do the square root of 8 times 6, which is the square root of 48. And then you need to reduce the square root of 48, and that's going to be the square root of 16 times the root of 3. Again, I use 16 because it's the largest perfect square that goes into 48, and therefore 16 becomes 4, radical 3, and therefore that is our geometric mean between those values. And that's all that means. So make sure you understand for the tomorrow's lesson that the geometric mean is the square root of A times B. Now this has a unique application in right triangles. So when we look at this right triangle, you actually see that I have 3 right triangles here. But what I really want you to do is I want you to focus on 2 of them. So I'm going to outline the red one here. So we have our big right triangle where the right angle is up here at the top. Notice that the altitude is being drawn from the right angle. That's extremely important. So the rules you're about ready to see here only apply when the altitude is drawn from the right angle. And then we have a smaller blue triangle that's also a right angle or right triangle. So I'm going to start out by labeling some sides here. We're going to let this whole thing be the hypotenuse of the red triangle, and we're going to call this the short side over here. We'll call this A, B, and then we have the hypotenuse over here, which we will call that C. And so now if we take a look at this, if we do, well, I'm trying to think about how to kind of get you guys there. So basically, if we look at setting up proportions, remember that the corresponding sides must be proportional. So if we set this up as hypotenuse over leg is equal to the hypotenuse over the leg. If I take my blue triangle, my hypotenuse is C over the A, and that will equal, now the A is the short side of that triangle, so what's the short side of our big red triangle? That's also C. So that's our leg. The hypotenuse is H, so H over C. So this is actually kind of an interesting outcome. Because what we're starting to see here then is if you cross multiply, we get C squared is equal to A times H. Remember, A is just a part of the hypotenuse. The hypotenuse is the whole length. A is just the side of the hypotenuse that is connected to that leg. Okay, so that's really, really important that you understand that. So therefore, C is the geometric mean of A times H. So when we talk about this in a bigger geometric sense, if we label the vertices A, B, C, and D,
Austin Boyd, please report to the main.
We can get the relationship where the length of AB is the geometric mean of the entire hypotenuse, BC, times the part of the hypotenuse that's adjacent to AB, which in this case is BD. if you're looking for AC, it's the same concept, except for now we have the whole hypotenuse, which is still BC, and which part of the hypotenuse is now adjacent to AC. Okay, that's going to be the CD. So that's one of the things I really want you guys to take out of this. If you're in a right triangle, this is the model I want you guys to know is right here. Okay.